Hi. Hey everyone, so today I want to walk you through a vulnerability operations center that I have been building. Vulnerability scanners are very good at finding technical issues, but scanner severity alone does not always tell a team what needs attention first. A critical finding on an isolated test system may not represent the same risk as a high severity vulnerability on an internet-facing production server. Analysts still need exploit intelligence, asset context, ownership, deadlines, and evidence. This project brings those pieces into one workflow. It enriches normalized findings, creates a prioritized remediation queue, tracks decisions, and generates evidence packages. Everything you are going to see is the actual application running with sanitized synthetic data, no employer data, live scanner credentials, or production assets are included. So let me walk you through how it works. The first page is the overview, and this is meant to answer a simple question. What does the current vulnerability risk look like? Where should the team focus first? I can see 40 findings, including 21 critical findings, 26 connected to the CISA Known Exploited Vulnerabilities catalog. I can also see how many remediation deadlines are already at risk. The severity chart gives me the scanner view, while the trend shows prioritized exposure over time. This is not simply sorting by severity. The application combines technical severity with exploit probability, known exploitation, internet exposure, exploit availability, and asset context. That is why two vulnerabilities with similar scanner ratings can end up with different priorities. On the right, the application explains why the selected finding reached its score, preserving the evidence behind the decision. The scoring evidence panel is where the prioritization logic becomes fully visible. I'm going to use the log4shell finding as an example because it shows how several risk factors work together. The base severity comes from CVSS. CVSS is only one input in the policy. EPSS estimates the probability of exploitation activity. VPR adds threat informed prioritization, and CISA KV confirms that the vulnerability has been exploited in the wild. The policy also checks internet exposure, public exploit availability, and whether the finding is overdue. Each factor contributes a documented number of points. For this finding, those factors produce a score of 99 out of 100 and place it in the highest remediation priority. The scoring policy is repeatable, so another analyst reviewing the same evidence receives the same result. Opening a different row immediately updates the evidence panel, which makes it easy to compare why one finding ranks above another. The vulnerabilities page is the working inventory for the environment. I can search by CV, asset, owner, or finding identifier, then filter by severity, exposure, or CISA KEV status. For example, I can isolate internet-facing findings that are already known to be exploited. That gives the team a focused list instead of unfiltered rows. When I open a finding, I can see the affected asset, accountable, team evidence, due date, and recommended remediation guidance. Ownership is important here because a vulnerability does not move simply because it has a high score. Someone needs to know who is responsible, what action is expected, and when it is due. The operational details remain attached to the technical finding. Once a finding is prioritized, the application creates a stable local remediation ticket draft. The remediation queue separates draft, approved, and rejected decisions. I can open log4shell and see the ticket key, owner, deadline, score, and recommended action. Before approving it, I can add a decision note explaining what was validated. For this demonstration, I am documenting that exposure and ownership were confirmed. When I approve the draft, the state changes immediately and the decision is stored with the reviewer and timestamp. No Jira or ServiceNow ticket is created in demo mode. That external action remains disabled while the local workflow and integration evidence are demonstrated. Now I can move to the audit log and verify the approval event. The event records what changed, which ticket was affected, who made the decision, and when. This is useful for governance because the remediation result is not just status on a dashboard. It becomes a traceable record. The reports page turns the current workflow state into a point in time evidence package. When I generate a package, the application creates an executive risk report and a technical evidence report. The package also exports the finding inventory, remediation queue, and audit history. It creates 3 CSV files. The executive report is designed for posture, trends, and remediation status. The technical report preserves the finding level evidence needed by analysts and engineering teams. Because every file comes from the same workflow snapshot, the totals, decisions, and timestamps remain consistent across the package. The report history confirms when each package was generated and provides each artifact. The backend uses Python and fast API. Next.js powers the TypeScript frontend. SQLite stores the local remediation and audit workflow data. The scoring engine, synthetic data, reports, and automated tests will be included in the standalone GitHub repository. The current version is a portfolio demonstration, so the dataset is synthetic and external ticket creation remains disabled. The next phase could add a sanitized tenable import, scheduled enrichment, and optional Jira or ServiceNow connectors. The goal was to move from raw scanner output to explainable prioritization, clear ownership, measurable remediation, and audit-ready evidence. I would especially like feedback from people working in vulnerability management, exposure management, security engineering, or GRC. Let me know what you think, and thanks for watching.